Hey guys, time for another video. So in the last video or last class, we realized the special relationship in the 30, 60, 90 right triangle. And because we did a generalized proof to come to that realization, we know that it is true for every 30, 60, 90 right triangle. Today, we're going to do the same now for a 45, 45, 90 right triangle. Now, we want to prove that the ratio of the sides are A radical 2. So the way I'm going to start this proof is I'm going to start with doing a triangle. A square. Sorry, let me use black. We're going to go ahead and start with a square and call each side length A. Right? So let's have A, B, C, D. So we're going to have square A, B, C, D with side length A. And we also know in a right triangle, a square, that every angle is a right angle. So I'm going to go ahead and annotate that as well. Okay. So now the next thing I'm going to do, because we don't want a square, we want a right triangle. And we already have these right angles involved. So what I'm going to do is draw a diagonal within our square. Draw a diagonal from here to here. And the beautiful thing about this diagonal is it's going to bisect those angles. So right now, these angles are now no longer right angles. Each one is going to be 45-degree angles. So now we see that 45, 45, 90 right triangle, and we already have two of the side lengths, A and A. So once again, I'm going to go ahead and do the Pythagorean theorem to figure out this missing side X. So we could say that A squared plus A squared equals X squared. But we want to figure out what X is actually equal to. So A squared plus A squared, well, that's going to be, oh, it's not letting me write. Sorry. 2A squared. Once again, our job is to figure out what X is equal to, not what X squared is equal to. So I'm going to go ahead and do the square root on both sides. And we'll get X is equal to 2 radical 2A squared. But we could further simplify that. I could break this into A squared times 2, because 2 times A squared is 2A squared. And then the square root of A squared is A. We cannot further simplify radical 2. So we get X is equal to A radical 2. And we see that special right triangle. We proved it, that in a 45, 45, 90 right triangle, we have the relationship. Let me just go ahead and draw a new triangle real quick. So when we have a 45, 45, 90 right triangle, the legs are always going to be A, and then the hypotenuse will always be A radical 2. Now, with this fact, you're going to go ahead and look for other side lengths within these right triangles. All right? Good luck, guys.